This week, we have a great interview with Warner Losh of the FreeBSD project. We're going to be discussing everything from automatic kernel module loading, I/O scheduling, and of course, NanoBSD. BSD Now, episode 109, Impish BSD, recorded September 9th, 2015. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
And we're glad to have you guys with us this week. I know you're probably looking at that date and going, wait, did he just say September 9th? Is this a repeat? No, it's not. We're recording this early because this is the second week of BSD I think actually you're still at Euro, or are you at another conference?
This will be just before Euro starts, or just the day Euro actually starts. Is when this will air. And last week I was at a different conference, yeah.
That's right. So if you're out and you are in Europe and you want to get to BSD you have one day to make that happen. So do it now so you can go see Alan. I will not be there. I think that weekend I'll be up in Ohio Linux Fest. Mm-hmm. So if you're in the Ohio area or can make it down to Ohio Linux Fest, no excuses. Come on down and say hi. Mm-hmm. Love to see you. I think I'll be at the FreeBSD/IX Systems booth. So I'll be glad to just chat with you. I know I did that at Texas Linux Fest a couple weeks ago, and it was a lot of fun just hanging out with the BSD fans and just kind of shooting the breeze about BSD all day. Yeah. So good times. Definitely will need to come out and see us. Mm-hmm. But we're not going to leave you hanging, even though we've been gone a couple weeks. We do have a cool interview with Warner Losh, who's of BSD fame, of course. And we'll be talking to him here in a little bit. But before we do get to that, we do have to mention our first sponsor this week, which is going to be DigitalOcean, where, of course, we've been telling you for a while now, but you need to use that code FreeBSD now if you haven't already, because we don't know when they might take that down and it goes away. And that's a great way to get a $10 credit on running a DigitalOcean droplet. That's good for basically like 2 months of a VM. I mean, how cool is that? Running FreeBSD all from the web interface. Just click, and done, and your FreeBSD VM just comes right up.
Yeah, and the VM's all backed by SSDs, so you get great I/O performance. Has great tier 1 bandwidth and a full 1 gigabit per second uplink. And even the cheapest plan includes a terabyte of transfer every month. And, extra bandwidth is really cheap.
That is right.
And you get a super easy to use control panel. So, no excuses. You couldn't possibly be any easier or any faster to use. And they also have an API. So if you like the command line, you can do that.
That's right. So again, DigitalOcean.com allows you to just go ahead and get started. If you have an account, great. Plug in that code. You can use it if you've already made your account. If you haven't made an account, do that. It should just take you a minute or so, and then you'll be ready to go. And of course, FreeBSD is at your fingertips. And as we like mentioning, OpenBSD is possible in DigitalOcean as well. So refer to our website for instructions on how you could bootstrap that and get OpenBSD running in your droplet if that's your BSD of choice.
Yeah, they also have...
again...
They have locations all over the world to pick from, including Amsterdam, San Francisco, New York, London, Frankfurt, and Singapore. And they now have IPv6 available at all locations.
Nice. Yeah, that's great, guys. So yeah, definitely go get set up, and that's a great weekend project. If you need to spin up some services, or the nice thing is they have an API. So if you just want to spin up and spin down things on the fly, you can script that as well. So give DigitalOcean a try, guys, at DigitalOcean.com. Okay, and with that, we hope you enjoy the interview we have with Warner Losh coming right up. Okay, we're joined now by Warner Losh, who's currently with Netflix and just all-around BSD dude. And of course, we're really glad to have you with us today, Warner. We appreciate it.
Well, I'm glad to be with you guys today.
Well, great. Well, we got a whole bunch of stuff to talk about, but of course, as we get started, we want to find out a little bit more about you. So just give us your introduction. How did you first get involved with BSD?
Yeah, I, back in the 80s, was in college, so a few years ago, and we had a VAX 11750 that had, 3 megabytes of RAM and 40 users on it. And that's my first exposure to BSD, and writing compilers and linkers and all that kind of fun stuff for schoolwork, and also just playing around on it on my own time for fun. And from there, I went to SunOS and a number of different things, and wound up on FreeBSD a long time ago because Jordan wanted me to port some software to FreeBSD that he was using and really liked. So
What
I did
software
that
was
and was
that?
hooked. Yeah, and at the time, I was able to, with FreeBSD, I was able to dial into work and get work done. And with Linux, I couldn't do any of that. Slip was barely working and crashing the system all the time. So
What software was it he asked you to port over specifically? Do you
it's
remember?
something called Object Builder,
Huh?
which was a GUI toolkit and UI builder that implemented both the OpenLook and Motif interaction models. Because at the time it wasn't clear which one would win, and people wanted to write their software once and deploy it, in whatever environment made sense. And Jordan was a really early OI user, so he said, "Hey, why don't you port this to FreeBSD?" And so I took the weekend and got it all running on FreeBSD, and it spent a week getting FreeBSD up, but once I did that, I was able to do that in a weekend. That was because at the time this was like 1.0 gamma or 1.0 alpha,
Sure.
where sysinstall hadn't been written yet. So
Ooh.
Jordan literally sent me a clone disk and said, "Good luck, you're on your own."
That was when you had to be really hardcore to install BSD. Good Lord.
Yeah, and putting the disk in my computer, I zapped some stuff, and so there was a hardware repair involved, and it was, I'm surprised I, kept at it, but, Jordan can be quite persistent.
Yep. Oh, so you've been destroying hardware for a long time. This isn't a
It's
recent
not just laptops.
Okay. That's good to know.
Yeah. So I guess the next question is, what are some of the things we can blame you for? Some of your different contributions to various BSDs.
Yeah, I've done a lot of things in FreeBSD over the years. I've did the PC card and card bus maintainer for a long time, although seems to have faded. I've done a bunch of work on the PCI subsystem. Wrote a SD card stack that people are using these days, and just a lot of silly build infrastructure junk, some of which is useful and moves the ball forward, others just annoying when you go to upgrade. Hopefully more the former than the latter.
Sure. So specifically, I know you've been working recently on the kernel module autoloader. So tell us a little bit about what that is, what that does for us, and why we should be looking forward to it.
That's not actually in the tree, so I didn't include that in my list of accomplishments.
Okay.
But one of the things I noticed a long time ago was that pretty much every device driver that talks to hardware has some kind of table in it, the certain fields of which are plug-and-play information. This vendor ID, that vendor ID, and it struck me a long time ago that we could potentially somehow leverage this. And I talked to Hans Peter about this, and USB was much more regular than PCI or any of the other ones, and he implemented kind of a first version of this where he puts all this data into its own ELF section, and then has a program that parses it all out. And I thought, well, that's a good prototype. But then he uses it to generate a devfs script, which is really large, and he has to check in.
Sure.
And my thought was, well, we encode the module dependency information in the KLD files right now. Why not also encode the plug-and-play information in some kind of standardized form so that the normal tools could access it? You could get to it from the bootloader, you could get to it from the kernel, you could get to it from some UserLand program if you wanted to, and use that then to drive adaptation or adoption of like a more minimal kernel. This would be able to let us eject so much stuff from generic if we knew that the right module would automatically be loaded. And so I went through and started marking different modules in the tree. I've done USB and a PC card and some card bus and a couple individual drivers that have multiple attachments to go through and mark their tables as being the plug-and-play tables. And so there's a little tiny scripting language that says that, there's this field, it's so long, and it matches up to this information in the plug-and-play data, or the plug-and-play data that the new bus provides when there's a no-match event, so that we can start to match the two up. And so I've got the basics of all that done, and some experimental code on top of that to try to parse it and produce a devd.conf file that you can generate dynamically on each install world if you like. I'm not sure exactly where we'll put it in the system. Whether we'll do that or we'll just have a module that lives inside the kernel that can look at this information and go, oh, I see that this device appeared, no driver claimed it, and I can look up in the table that it'll probably match this driver. I'll go ahead and load that driver and see what happens. So that's what the device autoloading is about. And once I had that, then I was going to modify the bootloader so it would go through all the PCI devices that it could enumerate that were storage devices and load those so that we could boot them. There have also a few edge cases in the base system. You can't load a console right now because of ordering. You have to have the console up and available before the KLD metadata is processed. So there's an ordering issue there that we need to look into before we can move everything out of the kernel. But if we just had consoles and maybe a couple of file systems in there initially, we could potentially auto-load the rest. And looking a little further down the line, we could potentially do a similar technique for identifying different file systems that live on devices as well as Geom tastes them. But that's a more ambitious later project that I probably won't have time to do, but would complete the at least all the major things that we use the loader for now.
So potentially we could see like maybe a really slimmed down generic at some point where we don't have to have all these things on by default.
Exactly. Right now on i386 and AMD 64, there's a kernel module that's checked in called minimal. That is kind of the working goal. If you could have this plus the system that automatically loads the drivers, then for most people, they won't notice the difference between that and generic, except maybe a little bit extra memory.
Okay. So that makes sense. I'd love to see that.
Yeah, awesome. We're just like
so that's what I'm working on. The first part, the marking and modifying KLDXref to parse the data out and put it in a standardized form is in review now. The stuff that parses that data and generates the devd.conf file and some noodling around I've done doing it in the kernel, aren't really ready to share yet. So the first part I'm people like, and they want to see at least a proof of concept thing that parses it before I commit it, and I should have that sometime this month, and to go in, and I think that's going to be very exciting for a lot of people. I also think this will be quite useful for the embedded world as well. Now that we've got a rich loader environment, we can have less featureful generic kernels for the different boards, and then pull everything in as modules, so we don't have to build quite so much in the kernels. A small follow-on that a lot of people that are doing that stuff would be interested in. Maybe not the main thrust of FreeBSD these days, but certainly an interesting segment of people that'll be happy to see that.
Well, I had kind of a side question since you sort of mentioned it already, but you said all the KLD dependency infos in the modules. Is there a UserLand tool that we have at the moment to just easily list those dependencies? That you know of?
Not that I know of.
Okay. I have a bug.
KLDXref has a mode that I think it can read the linker.hints files that we have. but I'm not sure. I will have to find out. I'll have to see if there's an easy way to run that.
Yeah, I got a
'Cause there's code in
bug
there
report
that
I'm
looks
working
like it's
on.
reading and parsing it, and that's kind of what I leverage off of to do the devd.conf
Mhm.
thing that I want to do. But I haven't actually tried to see if that's a usable thing. I'll look into that and let you know.
Yeah, please let me know. We use
Mhm.
Grub on PCBSD, and one of the annoying things is it can't auto-load module dependencies, so I have to list them all in advance in the Grub script. And at the moment, I'm like, I don't think I have a UserLand utility where I can just say, okay, what are the dependencies of foo, and make sure all those get splatted into the Grub CFG. And for my own information, it'd be neat to be able to look.
Right. It's something also that would be potentially useful to have the boot loader already is parsing that information. Um, but I don't know if it gives you a way to spit that information the dependency tree out.
Okay.
If it doesn't exist, it's certainly something that would be useful to add.
Yeah, for sure.
But so in the midterm-ish end goal, minimum viable product maybe of this work, we would see things like all network card drivers wouldn't have to be in the kernel. They would all be modules, and it would just load the ones for the network cards you have.
Exactly. That's exactly right. The network cards, the storage controllers,
Like
maybe even
sound.
video cards.
Yeah.
Video cards are kind of a special case because some of them you need to load beforehand, some of them
Yeah.
you want X to load for you, and so there'll need to be some potentially some limits with that as well, and we'll probably run into those as this rolls out more widely. I'm hoping to have this done by the time we branch for FreeBSD 11. Is kind of the
okay.
Awesome.
time frame for this.
Yeah, I'd love to turn that on in PCBSD. I think that would be really cool to slim down the kernel.
But yeah, I can definitely see the advantage in embedded too, because like with those routers we were building at BSD CAN, they only have about 6 megabytes of space to store the kernel and the compressed root file system or whatever. And if you can shove more of that off to say, load the kernel modules off this external storage, then I can actually have more things that, I can use or whatever.
Exactly. So that's the auto loading system.
Okay, so now on to the next big thing. I'm especially interested in your work on an I/O scheduler specifically for SSDs and
Yes.
special types of workloads. Could you tell us a bit about that?
Yeah. So part of my job at Netflix is to optimize the fleet of FreeBSD servers that we have running. For people that don't know, just a little bit of background. Netflix is a video on demand service, and we provide all our video to the set-top boxes via FreeBSD servers. And one of the problems that we had was that we have to basically stop serving video from a small subset of servers so that we can put new content on, and then we can start serving video again. And the reason for this is that the SSDs that we're using, and generally most SSDs of a similar age, had problems when you write and read at the same time. You can easily get very bottlenecked if you're writing new data out while you're trying to stream other data, because as you're writing the new data out, it's invalidating old data with trims, and it's creating holes in the underlying log system that lives underneath your SSDs. And it basically needs to garbage collect. So it does a bunch of garbage collection while you're trying to serve data, and all that eats up bandwidth. So I wrote a I/O scheduler that says, well, for us, reading is most important, and writing isn't so important as long as we make some progress. So you set different parameters that say, well, if we keep the writing below a certain megabytes per second, 20, 25 megabytes a second, then these pathological effects on the read side don't happen. So we're able to load content while we're streaming out video.
Okay.
So that's kind of the problem it was designed to solve. And some of the other problems that I've gone on to solve since then is that Like when a system is low on memory, you want to give priority to the page daemon that's swapping out the pages to get more memory, so that you alleviate the memory pressure that the system has come on. So you want to give those a bit of a priority. Also, metadata reads for UFS is a useful area giving priority to, because that means that you can get to your the data reads more quickly. You can get those queued more quickly and reduce the latency to serve, in our case, to serve video, but in other people's cases to get the data moving into the disk. Right now, it's very lockstep, and since there's no priority, if you've got a bulk data transfer going on, that can delay reading in the metadata to figure out where the data is. So you get some choppy performance, and this, at least so far in the tests I've done, seems to even that out a bit. A lot of the specific code I've written for Netflix isn't necessarily applicable to all workloads, but the infrastructure, I didn't write it just for Netflix. I wrote a nice infrastructure and plugged bits in for Netflix so that we could control our workload. It's a pluggable system that anybody can plug other pieces into to expand it for other areas that people might want to do better I/O scheduling, to give a certain class of users preferential treatment over other users, or give a particular process a higher priority over other processes. There's a number of different policies that you can put into place using the building blocks that I have.
Yeah, well, I could see some other workloads you might actually want the other way around, where I want the writes to have priority over the reads.
Yeah, and this is certainly flexible enough to do that. You can say, I want reads to have priority over writes is one thing. I want to limit my write bandwidth to this. I want to limit my read bandwidth to this. I want to limit my IOPS for each of these operations to this, to a particular level. And I want you to, one of the latest things that I've added is, in addition to having a static limit, no more than 25 megabytes, you can say, as long as the I/O latency doesn't, is less than, say, 4 milliseconds. You can all these numbers I'm giving are parameters that you can adjust. As long as the I/O latency is for reads is less than 4 seconds, write as much as you want. But as soon as the read latency goes above 4 milliseconds, start to throttle back the I/O, to just throttle back the writes, so that the reads don't suffer. And we've deployed that, and that works relatively well. One problem with that, though, is if you're throttling writes and then hit a situation where you have a lot of memory pressure, you can't write the pages out with the swapper to reclaim the memory fast enough to alleviate the memory pressure. So it makes out-of-memory situations a little bit worse, which is why I was looking at giving priority to those sorts of things. So it's a very dynamic system that tries to squeeze as much performance out of the different disks as you can. Most of our SSDs are one particular model, but this year we started buying a different model. So the scheduler needed to become more adaptive and respond more to different workloads, because although they're drives from the same company, they have different thresholds and limits, and the newer disks actually respond better to the dynamic steering than the older disks.
Well, that's encouraging.
So that's very encouraging.
So are some of those commits already in current, or is this something people can play with?
This is something I have a branch in Perforce. It's projects IO Sched. And I haven't updated it in a while, but this interview is a good excuse to go off and update it again, based on the most current stuff that I have in Netflix FreeBSD.
Okay. Well, this
So
interview will be
that's
airing in several weeks when we're out of town at Euro or when Alan's out of town. So maybe that gives you a little time to get
yeah,
it there by the time people see it.
Yep.
exactly. So yeah, I'll get that. I'll make sure that that's available for your listeners when this podcast is broadcast.
Cool.
Hey guys, hope you're enjoying the interview with Warner. We'll be back with the rest of it here in just a moment. But of course, when we take this break here, we do want to mention another sponsor this week, which is going to be IX Systems.
Yes.
And of course, the website for that, you guys should all know it by heart now, but come on, ixsystems.com, and be sure to throw the /BSD Now at the end of that there, and get in touch with these guys. And of course, let them know that you heard it here on BSD Now, where we're big IX fans, and they make, all the hardware I use for building PCBSD here is all running IX gear.
Yeah.
I got an IX workstation under my desk here that I'm using for my main desktop. A little mini box here, a FreeNAS mini.
I should have stacked all the boxes from the IX gear that I just got delivered to my basement up behind me here so you could see.
You should do that. That's right.
Yeah.
So yeah, me and Alex are just sitting surrounded by IX stuff. It's pretty awesome, and you should be too. Let's be honest. Let's not have any weak sauce in your server room or in your office. You need to be making a point to get in touch with the IX system guys so they can hook you up with the gear you need, whether it be something for the server rack or again even something small like a FreeNAS mini that maybe is sitting in your home server closet or under your desk in your office.
Yes.
They can do that and pretty much anything in between.
There's a good one for you. It's whether it's under load or under your desk.
That's right.
It's got to be reliable.
That's right. You expect that same level of quality and reliability regardless of the price or the size of it, whatever. But IX Systems makes that possible. So when you call those guys or send them an email or however you decide to get in touch with them, first of all, tell them you heard it here because they love hearing from BSD Now listeners because they're big open source fans and big on BSD, of course. But just tell them kind of what the problem is you're trying to solve before you start getting into the specifics of the hardware. Because a lot of times, and this is what makes IX so unique and awesome, is they will be able to tell you, oh, you're trying to do this. Well, actually, this is probably the better way to go. You'll save yourself some money or get more bang for your buck, better performance to accomplish whatever the goal is you want your server storage to be able to do.
Exactly.
And because these guys are sales engineers, they speak that lingo probably even better than you do.
Yeah. So depending on your workload, especially with ZFS, that changes the hardware a lot. It's like, oh, well, with you're just storing media, then a log device is actually not going to help you at all. So don't spend all this money on an expensive SSD that's just going to do nothing all day. But, if you're backing VMs on it, then yes, that's going to make a big difference. And it's important you buy the right kind of SSD because the wrong kind won't last as long and you'll wear it out.
That's right. So again, guys, that's ixsystems.com/BSD Now. Go there, get in touch with them, and of course, let us know if you have some feedback or if you've bought something from there. We love to see pictures of that or hear your stories of your IX gear out in the field. So, okay, with that, we're going to bring you back to the Warner review. Hope you guys enjoy it.
I think the other day you were mentioning something about looking at having GEOM avoid having to allocate memory during the process of swapping.
right. One of the things, one of the kind of the side things that I've been doing with the IO scheduler, anytime there's a problem that crops up on some subset of our machines, with disks, I get to look at it. There are a couple of issues with GEOM. One, when we got out of memory, we would try to do a back off and be nice and not do IO as fast to try to give the system time to reclaim memory so we could start to get the memory to allocate the BIOS to send them down the stack. But it was poorly implemented. It would basically limit the system to 10 IOPS for hours at a time, because each time there was a memory allocation failure, it would increment a counter. And, with the good work that Alexander Moten has done for the direct dispatch, we went from having just a couple of IOs at a time to potentially having thousands of IOs coming down and failing to allocate. So that would basically throttle your system for hours on end. If you had a lot of I/O come in, couldn't get the buffers, and then we would do this 10 IOPS for a long time thing, which would basically kill the performance of the system. So that in analyzing that bug, which I fixed, or at least I put a Band-Aid in. I made the pathological behavior be 1,000 IOPS a second instead of 10 IOPS a second.
Sure.
And have it, the number of allocation failures don't matter anymore. As long as you're getting allocation failures, we'll throttle. And once you stop getting allocation failures, we stop throttling. So it's a little bit more reactive to what's actually going on in the system. But coupled with that, it exposed a couple of problems in the I/O stack, which was that people have known about for a while. We don't allocate enough memory to handle the transaction all the way down to the hardware. So we'll go down a couple of layers, and then if we had a resource issue, we'll have to queue. And if that's an important I/O, that can be a real problem. So what you heard me talking about, Alan, was allocating all that memory up front to do the I/O, and then sending it on down the stack so that it could, so there's no stalls going down the stack as the different levels of geom do their transformations and need a little bit of memory to do the bookkeeping for that.
So allocate enough memory so it's going to be able to make it all the way to the end without failing.
Right. It's an all or nothing policy that you could choose to implement, so that you either have the whole thing and it goes all the way down, or you got none of it and nothing. Until you can get the whole thing, it doesn't go down. Related to that, in the swapper code and probably the page buffer code, if you have a mechanism to allocate memory and send it all the way down, it's very easy to use that mechanism either with a static array that you compile in, so you always know you have one I/O transaction you can send down, and you can always make progress towards alleviating the memory pressure. Or if you wanted to get more sophisticated, you could have your own UMA zone that you could allocate out of when everything else is not working, and you can manage the UMA zone and see how much is used and how often it gets used, and only use it when you're out of memory, and have the UMA zone so it doesn't expand, so it's there waiting in reserve, but it's not it's a pool rather than individual dedicated resources, like for each level or for each geom or for each consumer. It becomes something that's more integrated into the system, so that when you're swapping out, that you can send that all the way down, and that the swap out will basically never fail. And right now it'll fail and sleep until it can get the resources to send things down.
And that usually just makes it worse, right?
Yeah, which makes it worse, and in fact, theoretically, you can get a deadlock in the system if the only memory you have to free up are pages that you need to swap out to disk, but you need to allocate memory to send those to disk, and you can't. You've got basically a classic deadlock.
Oops.
Most systems have enough memory and are large enough that this rarely happens. Certainly, the systems in Netflix have 256 gigabytes of memory. There's always something else that's using and freeing memory, the network stack or something. But this will help with the pathological behavior, but it also should help with when you run out of memory and you need to swap out. The swapping should be faster and more reliable, and let the system deal a little bit better with that when it happens.
Yep.
Nice. Okay, well, changing gears a little bit here. Tell us a bit about the work you started at BSD Can on your OneWire temperature sensors.
Okay, the OneWire temperature stuff I've been wanting to do for a long time. I've got a house that some of the rooms are hot and some of the rooms are cold, and I want to know during the summer when different rooms get hot, how hot they get, are different cooling techniques more effective or less effective, and to do that with data. Right now, it's like, oh yeah, this room doesn't seem quite as hot. But, if I put a fan on the door, I'll start doing that. I'd like to be able to test that more, and also just kind of understand how my house is behaving. My house is a high efficiency home made out of with straw bale insulation, so it tries to use as many either passive techniques or time shift techniques. Like it brings the cold air in during the night, and then we close it up and keep that cold air in and let it heat up slowly during the day, more slowly than it's heating up outside. So, and that saves us a lot of money and is more environmentally conscious. But in order to make most use of that, we need to have good data.
Sure.
So I bought a bunch of OneWire sensors on eBay. I have some here on my desk. I bought these on eBay.
All right.
They're ones that you saw at BSD Can. And there's a company in China that, if you're willing to wait a month and a half, they sell the individual chips for like a tenth of what you pay in the US. So I have a big pile of those as well that I'm going to hook up. So I started on this a little bit actually before BSD Can, putting together the OneWire system. OneWire is a set of sensors, not just temperature, but primarily temperature that Dallas Semiconductor designed and developed years ago. They, as the name implies, you have one wire on the bus. You can do one wire plus ground, so that all these devices share the bus, and you have ways of interrogating what devices are on the bus, addressing individual devices on the bus. And the code I wrote basically does all that. It'll figure out what's on the bus, find the right driver for it, find the right code to use, and then if it's the temperature sensor, it sits there and pulls the temperature sensors every so often to find out what the temperature is, and publishes it with a syskittle so that you can look at that and do whatever you want to do, whether it's just report the data. Maybe you have a control loop. You're trying to keep a refrigerator area at a certain temperature, so you could turn the refrigeration on and off. Whatever you want to do, that data is there for you to use it.
Okay.
And there was a lot of interest at BSD Can for people wanting to have a couple of sensors around the house, or maybe one inside and outside, and have this be something that they could look at some kind of database to figure out what's going on for whatever their situation is.
Yeah.
Yeah, my little server room, for example, would be kind of cool.
Yeah, my server's getting too hot. I have to shut it down, or
Right.
the air conditioner. Check to see if the air conditioner broke.
Yep. Makes sense.
Yeah, I have a server room in my basement as well, and it's like, so it has a dedicated air conditioner, but I wish I had more control over it. And,
Yeah, so I have one of the things, the previous guy that owned this house was a little bit, he pulled a lot of different wires to every room. Audio, video, satellite and cable TV, phone, and network. Goes to every room in my house. And since we don't, we only use one of the phones, all our phones are wireless, we only use one of the phone jacks. I'm hooking all the temperature sensors up to the phone connections that are in all the rooms, so I can just plug it in with an RJ45 or RJ11 jack, and it shows up on the network. The OneWire network that I'm building out. So.
Cool. Yeah. Other question here is a bunch of viewers actually wrote in to ask about Nano BSD. And when I asked in the chat room, I was told you were the person to talk to about that. So could you tell us a little bit about what it is and what it's used for?
Yeah, Nano BSD is a set of shell scripts that are used to build a subsetted FreeBSD system. And it also brings along with that kind of a stylized way to do configuration files, so that you can upgrade the OS without stepping on your configuration files. Paul Henning Camp wrote it for some stuff he was working on years ago, and handed maintainership of it over to me a few years ago. So that's, in a nutshell, what
That's
it
kind of what it does. All right. Well, is it still actively used? I know there's a lot of different things out there now, like Crochet, Cobbler, MFS BSD, or the Rodon ZFS system used in FreeNAS and Fudo. So is Nano BSD still actively maintained or used, as far as you know?
Nano BSD is still actively maintained. I'm a little bit behind for reasons I'll get into in a few minutes on updating it. NanoBSD is one of many ways that you can create a system. The different there's different ways to create the system: Crochet, the root on ZFS, even the stuff that the release engineer uses to produce the FreeBSD images, all create different systems. One of the things I didn't want to do when I updated NanoBSD was to hard-code all the data inside of NanoBSD and have it only available for use with NanoBSD. I wanted to make it so we can take a step back and create a set of tools for generating FreeBSD images for a variety of environments, so that right now there's, like in Crochet, there's special knowledge about, well, on a Raspberry Pi I need to do this, and for a BeagleBoard Black I need to do that. And those are very specific things. I need these particular ports to get U-boot. And then I need to create the disk in a particular way, and all that knowledge is hardwired into Crochet, which is kind of a shame because nobody else can use it unless they go and copy Crochet directly. And then if it changes or evolves as like U-boot changes, then you're out of luck. You have to copy it again. One of the things I wanted to do was to, like for the U-boot problem, make each U-boot port that we're using now have a shell script that would create the image for that particular thing. I wanted to have a set of wrappers around Gpart that would handle the mechanics of what, right now has different copies in NanoBSD and Crochet and all these other things, so that we could have them in the base system, and we could still get the really useful experimentation and, hey, I want to implement this idea, or this doesn't fit well with what I need, and have the flexibility to do that, and give a richer set of tools for people to build on, rather than having to go to all the low-level details for all these different things, which becomes a maintenance nightmare as the number of these systems proliferates, because there's probably half a dozen others that aren't in the tree that different people have talked about, that are probably will never be in the tree, but have to still do these same low-level details. And some of them are deciding to deal with it by saying, well, we only support Raspberry Pi and the Banana Pi boards. Those are the only two boards we're going to do, and everybody else, too bad. And to deal with the complexity that way,
which is a shame.
That's my goal is to basically create these tools and update NanoBSD to use them, rather than just hack NanoBSD and move on. We use it at Netflix to deploy our systems today, so I can find some time to work on it. But we're not in the business of deploying systems. We're in the business of streaming video. So most of my time needs to be spent on things that make the video go faster. So it's the updating has been a little slow going. I've been working on it since the beginning of the year.
Well, because one of the compelling things about NanoBSD was the way you do an update, right?
Right, exactly. That's why we use it. Is we can copy an image onto a spare partition. We can download the image into a big data area and then copy it onto the spare partition and reboot and have a new system. And if that fails, we've got automation to fall back to the old one. So we've got hundreds or thousands of machines out in the field, and 90+% of them are running our latest firmware that we roll every 6 weeks. And we don't have really the time to go out to each individual machine and babysit it if something goes wrong. And NanoBSD is very automatable and very configurable. We can put exactly what we want on it, upload the image to a central server, and then have all these machines grab the image and do the upgrade. And either they work and they have the new software, or they failed and they have the old software, and we get a report about that.
Yeah.
Okay.
So do you have any future plans for NanoBSD besides just the infrastructure maintenance type stuff?
The infrastructure maintenance is one, and one of the things I'd like to include in that is basically the ability to build a NanoBSD system without root. When NanoBSD was made, you had to have root to build a FreeBSD system, so it didn't care. Now a lot of people care. And the other thing that would be useful to do would be building like an ARM image on AMD 64, where you can use the work that Sean Bruno's done with the QAMU user emulation to create systems that are native ARM v6, but built on AMD 64 when you have ports that don't support native cross-building. And there's still a lot of ports that do that. Baptiste has been working on a lot of different ports to get them in shape to do native cross-building, but his work isn't ready on a wide enough scale. So Sean Bruno has done this as a stopgap until that's ready. And it might be, there might be some ports we never do because the effort is just too large and the payoff is too small.
Yeah. Do you think there's room for something like more tooling and more documentation on how to actually build an appliance out of FreeBSD?
I think there is. I think that's, I could probably do, or a number of people even could do a full day tutorial on how to build an appliance. Right now, there's a lot of knowledge, but it's more tribal knowledge. It needs to work its way into the handbook. There's a lot of that tribal knowledge also needs to work its way into scripts and automation, rather than just be, oh yeah, you got to do this funky thing, oh that funky thing. And if you're building a network appliance, you have to include these things. We need to step up our game and provide a richer set of configurations and tooling and documentation. The documentation is not just what the tools do, but also kind of an overview of what you can expect from a FreeBSD appliance and what some of the different trade-offs you would make to choose which tools to use. Have kind of that high-level stuff. And none of that, what's there now is very spotty. I don't want to say none of it's there, but a lot of it's missing.
Sure. Yeah, and I think it'd also be interesting to see some of the techniques that NanoBSD uses it uses the GPT partition flags, right? Like boot me and boot failed or whatever, to detect when to switch. A way to apply that to ZFS, but with ZFS, there's only ever the one partition, and you have multiple data sets inside of that. But at the bootloader phase, you can't write to ZFS, and so.
Right.
Maybe even just if the ZFS partition has the boot failed flag, try the second data set instead of the first one or something would be interesting.
Right. And that's some of the tools that we need to improve on. It's only been very recently that you could boot off the ZFS at all, and now that we can do that, we need to be able to
get feature parity with
have feature parity with.
Booting UFS.
With UFS.
Cool. So what keeps you motivated to work on BSD and work on all these projects?
It's fun. It's a fun group of people to work with. There's some interesting and challenging problems that challenge my intellect, or challenge my just brute force ability to crank something out. And it's fun and enjoyable. It's a tool that I can apply to a number of different situations, and any additional work I have to do to make it better or to make it fit that situation, is small compared to writing it all from scratch. So that's what keeps me motivated. It's a fun thing to do. There's good people using it. The tools are very rich and featureful, and it's hard to get something significantly better that's easier to deploy. So
cool. Right. Do you have any hobbies outside of BSD?
I have a couple. In the winter, I like to ski. Although as I've gotten older, I've been doing less and less of that. As my joints age, they don't like being abused that way. So I do that. I do some woodworking as well, making simple furniture. And lately, I've been doing, since I moved to the house out in the country. There's a lot of landscaping that needs to be done with it. So that's been my hobby on the weekends lately. I gotta stain this and put rock down here and put mulch down there and all this stuff. So it's almost risen to the level of a hobby.
All right, there you go. That's what happens when you move to the county, I guess.
Yep.
Well, as
I
we
really
close,
like the place. It's a lot of work, but it's looking nice because of that. So.
where are you located now? You still in Colorado?
Yeah, I'm still in Colorado. I'm in Brighton, Colorado, just northeast of town.
Okay, nice. Well, as we wrap up, anything else you want to mention here?
No, not right now.
Okay.
Thanks for having me on.
Yes, thanks for coming.
And talking to me and thinking my stuff is interesting enough to let other people know about.
Oh, for
definitely.
sure.
I'm flattered. Thank you.
Yeah, this was great. Thank you so much for spending the time with us today, Warner. Okay, we're back from the Warner interview. Hope you guys enjoyed that. And when you get a chance to come out to like BSD Can or some of the conferences, he's sometimes there. So now you know what he looks like. You can come say hi in person. Another excuse to get out to a BSD conference. But as we close the show here, of course, guys, a couple things first. First up, we need to mention the last sponsor, which is going to be TarSnap this week, where you can go and get set up at tarsnap.com, where else, and get your account created and download a client for just about any operating system or platform under the sun. They might even have Sun.
I think it's on there.
Too. I mean,
yep, Open
right?
Indiana. Yes, Sun
go.
is already on the list.
Okay, well, that worked out perfect. And of course, if you don't want to download the binary, which, let's be honest, some of us are more paranoid than others, and probably for good reason, you can audit the source code and compile it yourself. How cool is that? How many backup solutions offer that?
Exactly.
Come on. So definitely go to tarsnap.com and let them know, of course, if you talk to them that you heard it here on BSD Now, and get signed up, set up your account, put a couple bucks in there, and then start doing your backups both safely, reliably, and fully encrypted from the moment it leaves your box, which is the way all backups
before it
should be
even
done.
leaves your box, I guess, right?
Yeah. Before it goes out over the NIC or over the wire, it's already fully encrypted.
Yep.
So yeah,
And
every
only you
backup
have the keys. That's the
right.
important
Yeah, so
thing.
don't call him if you lose the key, because
Yep.
he can't get it back, and that's a good thing. That's a feature.
Exactly.
So we don't want to be able to retrieve data on the remote side without the key. So again, guys, tarsnap.com makes it easy. Get signed up, and of course, we love to hear your disaster recovery stories and how that saved your bacon, because we've all been there once. It's never convenient. Why is it always going to be 3 a.m. when the system dies?
Yeah.
Why can't it be when you start the day?
Yeah, it's always right when you're in the middle trying to do something important and you're in a hurry.
That's right.
Is when
That's
you
right.
accidentally delete the wrong file or whatever.
That's exactly right. I've never had one where it's convenient.
Yeah,
But anyway, RSnap makes it convenient to at least get the restore done.
Yep, and it definitely does not hurt your wallet. I've been doing my backups since January 1st, and I'm still at like $1.20.
Nice. Yeah, so no reason you guys shouldn't do that. It's so cheap, and everything it offers, there's no reason you shouldn't be using it at all. So, okay. Well, as we close the show, guys, no feedback and questions this week because we're recording this obviously well in advance.
This was 3 weeks early, actually.
Yeah, because Alan's going to be gone for 2 weeks, and I'm gone in Ohio this weekend. But the good news is we'll be back with a live episode next week with probably 10 times the amount of stuff to talk about now because so much stuff has happened.
2 weeks without a show, without a live show, and like 3 conferences we'll have been to collectively.
Yeah.
There's going to be a lot to talk about.
That's right. So you can expect a jam-packed episode next week, and we'll look forward to doing that with you live. But of course, as we close the show in preparation for this, while we've been gone, maybe you've seen something cool out on the internet or some new BSD news. Maybe we missed it because, we've been on the road, and you know how hotel Wi-Fi is. It's usually pretty bad.
Yep.
So try and send us that info to feedback@bsdnow.tv so we can make a note of it, make sure we cover it in next week's episode. And I don't mind if multiple people send in the same thing. That's fine. It only takes me a second to delete and get the one that was relevant. But just send it in to make sure it doesn't get skipped over. And of course, if you have any people you want to suggest for an interview, we appreciate getting that info in advance as well. Send us their name and email address, and we'll get in touch with them and get that scheduled. And any other topics or stuff you think needs to be discussed on the show, we, of course, love hearing that as well. So again, feedback@bsdnow.tv. Don't necessarily tweet us or leave comments on Reddit or whatever. We probably won't see those.
The email is the best way to make sure we see it, and we definitely could use your help making sure we get all the right stories and talk about what you want to hear about.
Definitely. So again, look forward to talking to you guys live next week, and we will see you then.